I post a link to the YouTube playlist on Canvas. There's already a link to the playlist on there. There's just no videos in it because this is the first one. So, all right, here we go. Our big goals for today are to review interval notation and analyze functions. And specifically, we're going to be analyzing functions as they compare to 0. So we're going to do 2 of these problems. We'll do the first one together. I'll work through it with you. I'm going to ask you to do the second one on your own. So here's my first function. This looks like a polynomial function. I've got it written out in factored form. This is not so important. What I need you to focus on right now is the graph itself. We're going to be looking at this function and analyzing what x values for this function give us some points that are either on the x-axis, and I'm going to color code these. So I have 3 points where the graph is on the x-axis, where the graph has a y value equal to 0. We also want to look at points where the y value is greater than 0. That would be this region here and this region here. And we also want to look at x values where the graph is less than 0. That would be this region and this region and this region. So we're going to be analyzing these and giving our answers in interval notation. When I'm doing this, I like to make a graph on a number line. The reason we're doing this, by the way, is our next lesson we're going to be finding domains of functions algebraically, and our answers are going to look a lot like this. So I want to get us good and familiar with interval notation. So just a quick reminder on interval notation. Do you guys remember when do we use brackets and when do we use parentheses? Open dots and closed dots. Which one? What does infinities always get? What one? Yeah, infinity always gets parentheses because you can't get to infinity, right? It's never included. And then these kind of, I call them sideways mustaches, these curly braces. That's if you have single individual values, right? Okay. So here we go. Here's our first one. So it's asking us, and I'm just going to put a copy. This is the same graph just so I can keep it on the screen. This is asking us to find the values where f of x or y is equal to 0. We said a moment ago there were 4 places on this graph where that happened. So I'm going to, on my number line, just make note of these. I'm doing them as solid dots because they are included in the graph. And they're not regions, they're just single individual points. So when I write this in individual or in interval notation, I'm going to list them inside of these curly braces from least to greatest. So -1 and 2, 3, and 4, all with commas in between. And there's our first one. All right. We're going to move down the page from here. This is going to look a little bit different from yours because I'm going to keep my graph here and slide my paper up. But we're doing now f of x greater than or equal to 0. So these would be the regions, or sorry, greater than, not greater than or equal to, greater than. These would be the regions where the graph is above the x-axis. So let's do this as a number line first. It's above the x-axis. It looks like between 2 and 3. So I'm going to put it, I'm going to put a bar here between 2 and 3. And also from 4 to infinity, yeah, because that arrow's showing us it's going to keep going. Now I want to put some dots at the end of these bars. Anybody want to be bold and tell me, are we going to have solid or open dots? Open dots because greater than but not equal to, right? So open dots because, now if that had been greater than or equal to, then we would have, those would be closed dots, but these are going to be open dots here as well. So it looks like we have 2 intervals. We're going to write this down in interval notation. One of them starts at 2 and ends at 3. And we're not including the 2 or the 3, so those are going to get parentheses. When we have more than one interval, we will use the uppercase U. It stands for union or intersection. No, union, not intersection. My second interval starts at 4 and ends at infinity. We said infinities always get parentheses. Any questions so far? Is this even familiar? Did you guys have questions? We good? All right. There's a clipboard in the back of the room. Since you're squeezing in on the ed, if that would be helpful to you, you're welcome to. Okay. All right. Flexibility is a wonderful personality trait. What's going to be the difference between these two? Yeah, it's the same regions, right? I mean, I can't see my graph now. I can. It's still these same two regions. It's just now we're including 0 as well. So these open dots turn into closed dots. So our interval notation is also going to look very similar, except we're going to have some square brackets in place of parentheses. All right. Yes. I didn't do a very good job color coordinating. Sorry. I said I was going to do that, but I didn't. My apologies. You're right. They should be green. With purple in the solid dots, right? Screwed it up. My bad. I'll do better on the next few. All right. Hey, if you ever wanted to get really fancy with this, you don't have to do this, but just in case you ever see this notation, this means that the x values we're interested belong to this set of numbers right here. So it's a little e, it's epsilon. It's a lowercase e, epsilon, and it means the solution to this is all of the x values that fall into the interval between 2 and 3 and the interval between 4 and infinity. Okay, so I would read this as x is a member of the set or x belongs to. Just in case you see that, you don't have to write it. All right, this next one seems like it would be pretty easy. It's kind of the inverse of what we had here. We want all of the x values that are on this graph where the y value is not equal to 0. So everything that's above and everything that's below, but nothing that's on the x-axis. So the number line for this is going to be the entire number line with just 4 holes in it. There's going to be a hole at -1 and at 2 and at 3 and at 4, but everything else on the number line is going to be filled in. When we write this out in interval notation, it's going to be kind of long, because how many intervals are we looking at here? 1, 2, 3, 4, 5. I'm seeing 5 intervals. So start writing them. Put some U's in between. So let me color coordinate this. So this should be blue. Man, I'm doing a bad job with my color coordinating. It's blue because it's below. So my first interval starts at negative infinity and goes to -1. Does not include -1. My second interval starts at -1 and goes to 2. Doesn't include either of those. Go ahead and write me 3 more intervals for that. Okay, any questions on that one? All right, next up we got f of x less than 0. So we're looking for y values that are less than 0 or below the x-axis. Now when I look at this graph, I see 1, 2, 3 regions. My question to you is, are these two regions going to be separate or are they going to be joined together? They're going to be separate? In other words, are we going to include -1 in the solution to this? Is that x value of -1 give us a y value that is strictly less than 0? No. We're not going to include -1. So when we go to graph this, there's going to be a hole at -1. We are going to include all these x values to the left because we're below the x-axis to the left. And also to the right as far as 2, but not including 2. And then we will also be including x values between 3 and 4, but not including 3 and 4. So that is 3 separate intervals. Go ahead and take a moment and write that in interval notation. Some expectations, when we write things in interval notation, I'm going to insist that we start with the smallest number and work to the right. So please start us at -infinity and work to the right. What changes when we include 0 as well? Kind of same things. It's the same thing that happened over here. These open dots are going to become closed dots, right? That is a great question. Would we not have a dot there? Now, I would say we could have a closed dot if we like. But I'm going to come back to your question in just a moment. Let me go ahead and draw this as I described it. So the same graph, except we close up our dots. Oh man, I just caught a mistake that I made. Anybody else see a mistake that we made earlier? We'll come back to that. I want to talk about your question though, because it's an excellent question. Does that dot need to be there? Are these two separate intervals? Is there a gap in between them of any size? No. So when we write this down, this should all be one interval. Now, if you wrote it as two separate intervals and you put square brackets around your -1 on both sides, I would give you most of the points on a test for that answer. But I would expect that the simplest way to write this would be to write it as 2 intervals. So that dot really doesn't need to be there, but when I go to write the interval, I will not be writing this as 2 separate intervals. So it's going to go from -infinity straight through to 2. There are no breaks between -infinity and 2. There is a break between 2 and 3 though, so we'll need a separate interval here. And that would be it. Now, I would expect that some folks might want to write it like this. Yes, thank you for letting me know. That is technically a correct answer, but is not the best answer. Yeah, well, because if you look at the graph, this is saying find all the x values where the y is either on the x-axis or below the x-axis. And if I look at this graph, from over here all the way straight through to 2, it's either below the x-axis or on the x-axis. There is no place in between negative infinity and 2 where it stops being either on the x-axis or below the x-axis. So it's all one continuous block of, yes, this does satisfy that. So it should be a single interval. Other questions? Can somebody ask a question about the mistake that I made at the bottom of the page on the other side? What did I miss? There is an x value that I left off. What is the x value that I left off that should be part of this solution? -1 should be in there too, right? Because this says find all the x values where y is greater than or equal to 0. It's equal to 0 right here, just at that singular point. So this would be an example of a place where we would use those curly braces. It's not an interval. It's a singular point at -1. Tricky, tricky. Not on the one above it because what? Excellent answer, right? So we would not include this here because at an x value of -1, the y is not strictly greater than 0. Okay, this means it has to be above, and it's not above there. It's right on the line. All right, questions there? I'm going to ask you to skip the next page for right now. It's more of the same. We're going to go on to the page after that and talk about analyzing some functions. Reason we're skipping that is we're going to go down to collect our books in about 15 minutes, which will be how long it'll take us to get through this. And then I'll ask you to come back and try that other one on your own after we do that. So this is a review of some Algebra 1 and Algebra 2 stuff that I need you guys to know because we're going to be using this extensively in the next couple of sections. So some of this you're going to be like, wow, this is going way back. What shape would this graph make? It's a line. It's a linear function. It's a linear function. My expectation is that you guys know how to find the y-intercepts of any function algebraically. How do you find the y-intercept of a function algebraically? I hear a couple answers, and that's wonderful. I'm hopeful that every one of you was thinking plug 0 in for x. The y-intercept will always have an x value of 0. So for any function ever, I don't care if it's linear, trigonometric, or the power function, plug 0 in for x. So if we plug 0 in for x, I would find f of 0, which is -2 times 0 plus 4, which is 4. So 0, 4 is our y-intercept. Now, I'm sure most of you back in Algebra 1 could have looked at this equation and told me my y-intercept was going to be at 4. How about the x-intercept for any function ever? How do you find the x-intercept? If I give you an equation and say, find me all the x-intercepts, what are you going to do with your equation? To find x-intercepts, you plug 0 in for y. If it's on the x-axis, the y-coordinate would need to be 0. So I would take this function, I'd put a 0 in for y. That equation would look like this. 0 equals -2x plus 4. And solve that for x. And that'll give you your x-intercepts. Oh, I got some wonderful news for you guys. In Algebra 2, did they make you write like -4 on both sides of the equation? Still? Oh, you don't have to do that in this class. You just go to the next step. Like right here, you're not going to see me write divide by -2, divide by -2. We've graduated past algebra steps like that, x equals 2. I want to see the result of it. Now, many of you are going to choose to still do that because you're comfortable doing that and it makes you more confident in your work, especially on tests and quizzes. A lot of you are still going to do that, and that's fine. I'm not going to dock you for it, but you don't have to anymore. So x is 2, so that means our x-intercept is going to be at 2, 0. So 4, 0, 2, 0. We said it was a linear function. Back in algebra 1, is that the line you would have graphed roughly for that? It's a little crooked, but... Domain and range, are we comfortable with domain and range? We're doing a lot of that this time. Domain goes with x or y? Domain goes with x. The inputs that can go into this, what x values are all on this graph, on this line? All of them. All of them, yeah. Negative infinity to positive infinity. There's some shortcuts for how to write this. All real numbers. That is not an I and an R. That is a single R that just has 2 lines on the left hand. It's called the double bar R. For this first unit, I'm going to insist that every time we do domain and range, we write it in interval notation, though. Just this first one. Unit 2, you can start writing your double bar R's. How about the range? What y values are on this line? All of them. Where is this graph increasing? It's not. Yep, so that'd be the empty set. There is no other way to write that. Where is this graph decreasing? Everywhere. All right. Down at the bottom, this is similar to what we just did. Can you write for me in interval notation the x values for which the y is equal to 0? Looks like a single value to me. So put it inside of some curly braces. Where is y equal to 0? Y is equal to 0 when x is 2. Where on this graph is the y value not equal to 0? That's everywhere else, right? Everywhere except for 2. Everywhere except for 2. So that's negative infinity up to 2. Oop, I don't know why I wrote negative 2. It should just be 2. Negative infinity up to 2 and 2 to infinity. I'm going to leave the last 2 to you guys. We'll check them together in just a moment. Look at your graph and tell me where is this, what x values, for what x values are the y values greater than or equal to 0? It's basically that part of the graph there, right? Greater than or equal to 0. And then strictly less than. As you're finishing up, I'll pause here for any questions on that first column on that page. How you guys feeling? Is this, I mean, it's probably a little rusty, right? But is it like, it's familiar? You've seen this stuff before? It's clicking. Dusting off some cobwebs here. Anybody spend all money or all summer doing math? Algebra 2 worksheets? No? Me neither. Actually, I did quite a bit of math this summer. All right. Hey, one of the things that we're going to do later on this week and early next week, I need you to be able to look at something like x squared minus 4 and be able to picture exactly what this thing looks like in your head. And I want like a fairly fairly accurate graph. You should be able to tell me where your x-intercepts are, your y-intercepts, what shape it is. What shape is this thing, by the way? It's a parabola. Yep. It's a parabola. Does it open upwards or downwards? Upward. Oh, you guys are awesome. Awesome. All right. Sometimes it's useful when you're looking at a quadratic to write it in other forms. I'm hoping you're all comfortable factoring x squared minus 4. That should be, I can do that in my sleep. We said it was a parabola, that it was opening upwards. Can you algebraically please find me a y-intercept and some x-intercepts? When we do this, we're plugging 0 in for x or plugging 0 in for y and solving. Oops. Oh man, that's terrible. I'm hearing some discussion about there's other ways to solve that equation too. Did anybody do it this way instead? Did anybody say 0 equals x squared minus 4 and add 4 to both sides and take a square root? Totally okay with that. So then you would go to this, and we take a square root on both sides, and we're going to get 2. But what do we not forget to do when we take a square root on both sides of an equation? Oh, you guys are wonderful. Look at that. That's fine. That's totally acceptable work for that too. Just don't forget that plus or minus. We got an x-intercept. We got a couple y-intercepts. We should be able to graph this thing pretty reliably now. Let's just talk about domain and range for this one, and then we'll go on our field trip. A quadratic is a polynomial function. Last year you probably learned that polynomial functions always have the same domain. What is the domain of any polynomial function? Everything, all real numbers, which I'm going to annoyingly insist you write as negative infinity to infinity just for this unit. The range is not always all real numbers for polynomials. It's not for this one. Remember, when we're doing anything in interval notation, we want to go smallest to largest. So range goes with y. What is the smallest y value that we see on this graph? -4, and the largest is infinity. And I think one of those is going to get a square bracket because it is on the graph. Okay. All right, how you guys feeling? That wasn't too bad for our first day of notes, right? Down at the bottom for this? Yeah, absolutely. Thanks. Oh, the ones that I asked you to do over here? Yes, I'm sorry. I should have shown you those answers. Thank you for asking. That's what I came up with. Any questions on that? Hey guys, you guys are going to see me make probably 500 mistakes in this class. Maybe not 500. Maybe 100 though. So if you ever see me write something down and you're like, that doesn't look right, please bring it to my attention so that I can correct it too. Okay? But I'm feeling pretty confident about those. All right. So we're going to take a trip down to the library in a moment and get books. Don't leave yet, though. When you come back, I'd like you to work on this. Have you guys seen functions defined that look like this? No. We're going to be writing equations that look like this next week. It looks messy. That's okay. Hey, shh. Relax. Deep breath. Ignore that for now. The only thing you need is a graph, okay? The only thing you need is the graph. So ignore it. This isn't hard. This is just y equals x plus 3. That's this line right here. If you continued this line, wouldn't that be the line y equals x plus 3? And this is the line y equals 0. That's this portion right here. If you were to continue that, it would be y equals 0. This looks funny, but it's 1/2 x plus 2.5. That's this little portion right here. Rise over run is 1/2, 1/2 x. Or y-intercept would be 2.5 if you continued. It's not that big a deal. But all that said, you don't need to know anything about this right now to answer these questions right down here. You're just looking at the graph anyways, okay? Let me give you some instructions for going down the library. There's classes going on, guys. It's the first